introduce Professor Dilley. As you know, the weather is being used as a political tool of the left. Well, Professor Dilley is here to prove otherwise. So let's have a big hand for David Dilley.
Well, it's great to be back again. I have 37 years of research on climate, going back quite a ways, and I've developed what is called ClimatePulse technology. We're going to be talking about that tonight. It's based on proven science. The electromagnetic interactions between the Earth and the Sun, which control just about everything. My organization, Global Weather Oscillations, specializes in hurricane landfall predictions. We've been the #1 preseason predictor for 10 years in a row. El Nino predictions going out 2 years in advance, climate change research predictions, weather cycles, and I have ebooks on the website and about 6 videos on YouTube. If you Google my name and climate videos. So we're going to take a walk through climate change. It's going to be sort of like a murder mystery in a way. We're going to gather clues and analyze them, and at the end, put the clues together, and we'll see the whole picture. So it's going to be step by step. So it's sort of like a murder mystery, so you have to follow right along so you understand the conclusion. So here's the global warming cycles. The global cooling began right there. That was 950 AD or so. 200 years later, global cooling began. 230 years later from that, global cooling began. 240 years later, began. 230 years later, it began. And now, you take the last global cooling cycle began in about 1790, 1794. What's 230 of 1790? 2020. That's now. So if it's going by the clock, we're going into global cooling. That's why Canada is so cold right now, and I'm going to show a little bit more on that. Now, I talked about those strong 9-year cycles, where it goes very strong up in the Northern Hemisphere every 9 years. This is the actual cycle plot, 1990, 1999, and 2009. They come about every 9 years. I want to show you how important the gravitational cycle is here. This is the United States temperatures going back to 1880. You can see it was very warm now, 2030s. Gee, that was a 72-year cycle. Remember I talked about a 72-year cycle. But look at all these ups and downs. All those peaks are about 9 years. That 9-year cycle? Think that's a coincidence? ClimatePulse cycles, the Arctic. The Arctic and Antarctic is where global warming begins. It begins up there. And it also ends up there, and global cooling begins. The key is up in the Arctic. And we're going to look at the Arctic. First of all, we have our conveyor belt of warm ocean waters. This is off of South Africa. Conveyor belt comes up into the Gulf of Mexico, up the east side of Florida, Cape Hatteras, then it goes across and makes a loop again, cools down, then it warms up again. But there's a spur that goes up. There's England, Ireland, and Iceland. There's a spur that goes up in there. And we're going to look at that because that's a gateway to the Arctic. So what happens is, I showed you those 9-year cycles. When you have a global warming cycle, what happens is you get a warm plunge of North Atlantic water into the Arctic. This is the Netherlands over here. This is the European Strait, Ural Strait. So it comes up and the warm pool of water circulates around the Arctic. It takes 13 years to cool down, die out, and it's gone. 13 years. Okay, here's the 9-year cycles I was talking about, the strong gravitational cycles. We had a warm plunge of water into the Arctic in 1990, right on top of the cycle. Well, what happened in 1999? That was a warm cycle, a very warm cycle in 1999. Look at that, right on top of the strong gravitational cycle. Then in 2008 was the last one, where we had a warm one. So the global warming cycles, what we have is a very warm one usually, and a not as warm one on either side of it. So in 2008, that was our last one. So in 2008, warm water pool came up around. Takes about 13 years for it to cool down and fade off. What's 2008 plus 13 years? 2021. Boy, we're starting to see 2020, 2021 show up a lot. So, 2020, Arctic Ocean turning colder, freezing again. And global cooling is now beginning from the Bering Sea of Alaska east to Greenland. This is Greenland. This is what they call the melting days, how many days it melts in Greenland, days in a year. On the left side, where I've got it blinking dashed lines, this is from 2003 up to 2012. You can see the melt days were above normal. But look at what has happened from 2011 down to now. Greenland's cooling down. Cooling down a lot, especially this year. Off of Alaska, this is the Bering Sea in red, there's Russia. After years of poor conditions up in the Bering Sea, good conditions now look normal this year. This is the annual plot of the amount of sea ice in the Bering Sea. The black is the average amount of ice during a long-term period, and it peaks out March to April is where you have your greatest extent. You can see in November you don't have much. The dashed red line here was last year, 2018, you can see is way below normal, way below normal. And 2018 is when you heard it in the news, they had a 2-week meltdown up in Greenland, and it was in the news, Greenland melting. It was only a 2-week thaw. Here we are in February. The extent of ice in the Bering Sea is above normal. Greatest recovery in 11 years, greatest amount of ice. So everything's pointing to cool down, Greenland to Alaska. With global warming changing to global cooling, will the oceans continue rising? We keep hearing these forecasts. 2030, 2050, it's going to be way up there. Swimmers will be way up there in 2050. The IPCC, which is the Intergovernmental Panel on Climate Change, that's where everyone gets their information. They say sea levels will rise during the next 80 years 4 to 8 feet. 4 feet by year 2050. 4 feet. It's going to be some problems over here. Well, there's another organization, rise.org. They go around the cities trying to get them to build dikes and things like that. Their forecast from 2060 to 2050, 20 to 22 foot rise. That's why New York City's trying to build seawalls, and they're all afraid that we're going to have 4 to 22 feet of sea rise by 2050. That's a lot. Well, also the IPCC, this is their temperature projections, about 5 forecasts during the past 15 years. Red of their projections, and the actual is down here in the green. So they're wrong every time. So do we want to believe their forecast? Well, let's take a look at why they're so wrong. We talked about the sea level rise. 6,000 years ago, 23 feet higher than today. So it's actually gone down, but yeah, it comes up a little bit during the global warming cycle that we've been having here. That's normal. Okay, so Let's investigate it. Well, their 23-foot predicted rise, that actually happened 6,000 years ago. Did they put their forecast out 6,000 years ago? I wonder. They're a little bit late on their prediction. During the past 120 years, though, sea levels have risen 8 inches. They have risen. And that can be a problem. But also know that global cooling is coming. It's starting now, and it's going to come in big time in 2024. So what will happen with the sea levels? Will oceans continue to rise, as the forecasts say? Are we going to have a coastal flood disaster? Is that the disaster I'm talking about? Everyone's saying no. Okay, I showed you a map earlier. Here's the United States. This is in February. This is a computer model where the green, especially the purple, is the real cold air from Alaska over to Greenland. It's been sitting there all winter, having a very difficult time getting down to the United States. Typically, we get bursts of cold air, but it really didn't happen this year. Why? A lot of meteorologists are saying, why? Well, one reason is you look at the oceans. Here's the United States. The orange and red, that's all above normal, well above normal ocean water temperatures. And you can see that just about around the whole world. The oceans are extremely warm. And that's tending to change the weather pattern and block the cold air from coming down. So we have to cool the oceans to get global cooling going. So how are we going to do it? 3 ways. One way is global cooling. That's coming. So we know that's coming. It's waiting. The freezer door is up there. It's got the cold air, just waiting to open the freezer door and let it fall. But we have to cool the oceans. Second way is, and I'm going to show you a depiction of it, El Nino in 2022 and 23, followed by a La Nina in 2024. Now I'll show you what a La Nina does. A typical El Nino, this is the Pacific Ocean, where the ocean water that red says very, very warm along the equator, much warmer than it is this year. Very warm. That changes the whole atmospheric circulation. When we have an El Nino year, it's quite warm in the United States, a lot of storms. The opposite is what we call a La Nina, where the water turns cold in the Pacific. A La Nina. So we're going to take a look at that 2024. Are we going to have that happen? And that will help to open the floodgate. Third way is for ocean warm cool cycles. There's cycles in the ocean. Can we tie that in also? This is the ocean cycles. Red is a warm ocean cycle. We're in a warm phase of the ocean cycle. Look at that. It happened back in the 1940s, back 1870s. We can see the warm cycles going back. That's in 1540. You think human beings did that in 1540? Did we cause all these warm ocean cycles? We've been told we do. So we're looking at this. What happens, they alternate between warm and cool. The warm cycles, like we're in now, the ocean expands and sea levels rise. When the oceans are in a cool cycle, sea levels actually contract. The seas contract a little bit and sea levels can go down. So we can see we're right on the edge of falling off that cycle. And I say it's going to do it in 2023, 24. So let's take a look at that area. The last 2 cycles here. Okay, this is the sea levels since 1880, going up to now. During a warm phase of the ocean, 1930 to 1960, the oceans went up 2.8 inches. That's a pretty good rise in only 30 years. In the second warm phase, 1980 to now, it's gone up 3.1 inches. That's a lot, 6 inches gone up during those 2 warm ocean phases. Well, we had a cool phase back in 1900 to 1930. Oceans only went up 1.2 inches during a cool phase. Didn't go up much. We had a cool phase back in 1960, 1980, went up less than 1 inch. So you can see the big difference between a cool phase in the ocean and a warm phase. And we're heading towards a cool phase. Since 1880, we've had 2 cool phases. The ocean's only went up 2 inches. 2 warm phases went up 6 inches. That's the big difference between cool and warm, total of 8 inches. But cool phase, I have it boxed off because it doesn't go up nearly as much. Well, my prediction, 2025 through 2065, maybe even out to 2100, we're going to be a cool ocean cycle coming in 2024 through 2065, a cool ocean cycle during the period. Ocean levels, I expect to go down 1 inch due to that. Global cooling is coming in. That will stabilize ice melt, but we still may have a 1 inch rise. So overall, 0 for a rise. Compare the predictions, I'm saying 0. IPCC says 4 feet, rise.org 22 feet. So they're not even looking at the warm phase, cool phase of the oceans, and they want to continue to believe that global cooling is never going to happen again. Now we're getting to the unexpected climate change disaster. If the climate disaster is not global warming in the world in 12 years, if it's not that, what do we think it is? And it is not sea level rises, that's not going to be the climate disaster. And it is not carbon dioxide. Water vapor is much more powerful, and we need carbon dioxide. So what is the unexpected climate change disaster? Well, it is partially global cooling. And, any guesses? Volcanoes. They're monitoring several supervolcanoes that have been dormant for 160,000 years. Super. And I'm going to show you the difference between a super and a regular. Hurricanes are classified category 1 to 5. Major hurricanes are 3 to 5. Volcanic index, they call it VEI, goes to 1 up to 7. So what we're going to look at are 7s, and the supervolcanoes are 7 plus. But I'm mainly worried about just the 7s, but they are looking at 7 pluses. So where are they looking at the 7 pluses? One is in Chile. They say it's already at the critical pressure point, possible eruption, be the first time in 500 years. Second big one, Indonesia. Russia is also monitoring one, and they say it could have catastrophic consequences. Iceland, of course, they have a fear of one waking up. And there's always Yellowstone. Now let's take a look at volcanic activity and global cooling as it's tied into the gravitational cycles. Because gravitational cycles, I've showed you that they change dramatically as we go into global cooling. And it can change, the Earth can bulge by 1.4 kilometers, and we can have more volcanoes and earthquakes. Okay, there's our global warming cycles and cooling cycles. This big red one was a 7 volcano back in 946 AD. It probably caused what we call a year of no summer. And I'll describe in a little bit what a year of no summer is. Then we look as we go into the global cooling cycle. There's another 7 that's that they say might have triggered the little ice age. That probably caused a year of no summer. Then here's a big flashing one here, the Ring of Tudo in New Zealand. That definitely had a year of no summer. and we had some coming down these global cooling cycles, and most recently, have a flashing one here. This is in 1815, Tambora, down in Indonesia. That was a 7, caused the year of no summer in 1816 and 17. And what I wanted to show is, here we are now coming into global cooling, and I expect somewhere between 2030 to 2040 that we will see a BEI 7 or greater tied into the global cooling. This is God's world in 12 years, not burning up, but more ice and snow. Year of no summer in 1816, caused by Tambora. And is it coming again in 2030 to 2040? 1816, they had killing frost every month of the summer from Maine to Maryland. Doesn't fare well for your crops. Yellow snow in Europe. Potato and rice crop failures, Ireland, that started the big potato problem. And they had rice failures over in China. Next 30 years, 1/3 of Europe perished. Some of it was through famine, disease, and civil unrest. We only had 1.2 billion people on Earth at that time. We have 8.2 billion now. Global cooling is much more dangerous than global warming will ever be. Next 50 years, global cooling will cause shorter growing seasons, crop failures, food shortages. We saw crop failures this past fall in Idaho, Montana, up in Alberta and Manitoba in Canada. Early snow and frost, they lost a lot of their potatoes, corn, soybeans. That's just one section. So if we get when this big time global cooling comes in, it's going to be worse. Remember I said population 1.2 billion in 1816. Now it's going to have 8.2 billion in 2030 trying to feed them. Probably see population migration. So if you mix in a historic volcanic eruption, even plain global cooling, we're going to have food shortages. We're going to have problems. We're going to have years where we don't have enough food in the world. Even in the Bible, it talks about 7 years of grain. We don't. In cities, they have one day of food, maybe, most people. Now, if we mix in a historical volcanic eruption, which is very likely, we could have a possible year of no summer. Major crop failures, and I mean major. Major food shortages. Major civil unrest, and I mean major. You're going to have countries against countries. Countries seeking food, energy. The United States needs to plan. We must have strong borders, strong military, not rely on other countries for food, other items, and medicine. Now, I started this all off by saying government grants created most of this mess about global warming, about man causing global warming. That was a government grant system, pouring out money to the universities, and they just fed on it. And they had to keep putting out their literature on it. So what President Trump needs to do is drain the grants and bring in grants for natural cycle research. Climate change, the truth. Okay, do we have time for questions? Or? Thank you, sir. Yes, sir.
Where's Antarctica in all this?
Antarctica right now has its greatest ice extent in a long, long time. There's only one portion of it that has a meltdown. That's due to undersea volcanic eruptions. The rest of it's cooling down and more ice extent. So it's coming. Writing is on the wall.